I'm going to talk about conservative forces and non-conservative forces now. And I'll start by giving an example and giving you some kind of definition of what these are. So conservative forces, an example of a conservative force would be gravity. An example of a non-conservative force would be friction. For a conservative force such as gravity, the total energy change during some kind of process depends only on the difference between the initial and final positions of the objects involved. Because if we go through that process and come back to the original positions, then we'll find that the total energy hasn't changed. We call this type of process a reversible process. For a process involving a non-conservative force such as friction, the total energy change during that process depends on the path between the initial and final positions. So if we tried to go back to the beginning, we wouldn't have the same amount of energy in that system as we had before. And this is going to become a lot clearer once we talk about a couple of examples. So in the first example, we're considering a box which is under the influence of the Earth's gravitational field, and we're going to be pulling that box upwards with an external force of tension. I'm going to define the upwards direction as positive and the downwards direction as negative. Now going back to our definition of work, we know that if we apply that force upwards and that box is moving up at a constant speed, the external force that's being applied is positive. The displacement that box is has travelled is positive. And so the work or the energy change in that system of the box and the Earth is also positive. We've added energy to that system, transferred energy to that system. And we have increased the amount of energy by that work value, which is the force times the displacement. So after we pulled that box up, we're going to lower it now. We're still applying a force. That force is still in the positive direction because that's the external force. You need to apply that force upwards to keep it, to balance that gravitational force. But in this case, because we're lowering it, the displacement is negative. It's being lowered. It's going down. So in this case, the work is actually a negative value. So we're decreasing the energy of the system of the force times the displacement. So you can see here that this is a reversible process. The transfer in and out of the system of energy, those are reversible. We pull the object up, we increase the energy, we lower the object to the same original position, and we decrease the energy by the same amount. So our net change in energy of that system is zero. And that is a property of gravity as a conservative force. So when we go and talk about friction as a non-conservative force, and say we've got a box sitting on a table and an external force is being applied there, say a tension force to the right, we've got a friction force which is acting between two surfaces and it's heading back to the left to oppose that motion. Of course, work is being done on that system, but the work that is being done is being stored as internal energy. And we can't get that energy back. We can't, if we push it the other way, we don't take that energy away again. It's not recoverable. So the process of pulling the box across the bench or across the table produces a transfer of energy to the system which we can't get back again just by pushing the box back to where it was. So we can say that for a non-conservative force such as friction, that the energy of the system always increases regardless of the direction of the motion. So even if we brought it back to the beginning, you would still have an increase in the energy of that system. The internal energy of the system would have increased.